Hey Michael, I just realized your legs move in perfect harmonic motion. Why don't we determine a sinusoidal equation that demonstrates the relationship of the distance your foot is from the ground and the time that passes?
Oh geez, Alan, that sounds like fun. But wait, I'm dumb and don't know what that means. What's harmonic motion?
Oh, Big Mike, you didn't pay enough attention in math analysis class. In mechanics and physics, simple harmonic motion is a type of periodic motion that is sinusoidal in time and demonstrates a single resonant frequency. Or in other terms, it can be graphed using a sine or cosine function on a distance and time axis.
Oh yeah, I just forgot about that. So we can create a graph from data we find from my leg swing using a sinusoidal equation?
Of course we can, Big Mike. All we need to know is the amplitude, the period, the phase shift, and the vertical shift.
I remember that much. The vertical shift is the change on the y distance x-axis. In this case, because my foot is highest at 2 feet and lowest at the ground, or 0 feet, and the regular cosine graph oscillates between 1 and -1, there's a vertical shift of 1.
Very good, Big Mike. We have our first piece of equation now. We have the vertical shift. Next we can find the amplitude from the same data. Because your foot oscillates only 1 foot above or below the vertical shift, the amplitude is also 1.
Man, this is easy. Now how would we find the period of this full swing?
Well, Michael, because the normal cosine graph's full cycle goes 2 pi on the x-axis, we can convert our full cycle of 1 second to radians to make the correct proportionate period of our graph. To do that, we just divide 2 pi by 1 second and we get 2 pi, which is our period.
Wow, we're almost done with this equation. All that's left is the phase shift.
You know it. Yes. And to do that, we just have to figure out how long it takes for your foot to reach the top and the beginning of its cycle from the ground when the time starts. Since we see that it just takes half a second for your foot to reach the top of the cosine rotation, then that is our phase shift. Since it is a phase shift to the right on our graph, c will be negative in the equation because it's in parentheses with the x value, which will affect the direction it moves.
So we have all the information we need. To put it all together, we plug these numbers into the general equation of y equals a cosine b x minus c plus d. Here, a is the amplitude, b is the period, c is the phase shift, and d is the vertical shift. Since a is just 1, it won't matter. Therefore, we get y equals cosine 2 pi x minus 1/2 plus 1.
Very good, Michael. Now that we have our equation, we can draw out a graph for it. It's fairly simple. First, we can draw a dotted line at y equals 1 for the vertical shift that our graph will oscillate around. Then, we can move right from the graph 1/2 second and up 2 feet to mark where your rotation starts.
Then we can mark points at 3/4 second and 1 foot, 1 second at 0 feet, 1 3/4 seconds at 1 foot, and 1.5 seconds at 2 feet again, where my foot reaches the maximum on the other side.
We can continue this pattern for a few periods to get a good representation of this pattern. To finish it off, we can draw a curved line that goes through all these points to show the motion of your legs on the rest of the graph.
That's awesome. I always wondered why my legs' motion looked like in a harmonic motion on a sinusoidal graph.
Really? You're stupid.